Hey Psych students, welcome back for part 2 of our lecture on Module 6. This is a really big module that needs a lot of instruction. So, we talked about correlational methods, we talked about correlational studies, positive correlations, negative correlations, difference between those, and we discussed illusory correlations. Now, this is our last research method that we're going to look at for research methods, and that would be experiment. So the experimental design regards these certain ingredients, okay? The independent variable being the most important, the dependent variable, the random assignment, the control group, the experimental group, and some other things as well that are also seen in correlational studies, like random sampling is also used in experiments, right? Not random assignment, though. Random assignment is only used in experiments. So in class, you'll actually get to implement some of these terms and design your own experiment. Should be a fun activity that we'll do in groups. Now, when we look at experiments, there's one thing that we see kind of across the board, and that's that all of them have a hypothesis, right? And a hypothesis is a tentative, testable prediction where we're trying to prove something, right? And when we look at a theory, right, that's where hypotheses generally come from. We're either trying to revise that theory, further support that theory, or actually reject that theory. And so, in this case, my topic is teachers should get lattes delivered to them every class period, right? Or oat milk flat whites is my favorite. Okay, so my alternative hypothesis to prove this point would be caffeine helps keep school teachers more happy, right? And that would be my alternative hypothesis. Now, that is not proven true yet, right? It's my alternative hypothesis. It's a tentative statement. But in order to prove that, I also have to take my null hypotheses, which would be the opposite of it, and try to prove that null hypothesis wrong. So my null hypothesis would be caffeine does not help school teachers become more happy, right? And we do this through something called inferential statistics, which you'll read about in Module 8, and you'll learn about the p-value and the probability, right? Where that probability needs to be less than 95% in order for it to be statistically significant so that your research can be published, okay? You want that chance. Your research being due to chance needs to be very small, very incremental, so that it can be seen as significant and reliable research. Okay? Now, also, we need valid research, right? We want to have high validity, high internal validity. So, in order to do that, we need to have operational definitions. But we would need to operationally define the term caffeine. What does that look like? Okay? And there's so many different types of caffeine, and how much caffeine are you regarding to? And when we talk about happiness, our dependent variable, that which we're trying to measure, what does happiness look like? Think about this question here. What will I use to measure attitudes and beliefs? Generally, if we're talking about attitudes and beliefs or values and things like of that nature, we would use a survey, okay, after the experiment to measure our dependent variable, in this case, happiness. Now, what's the difference between true experiments and quasi-experiments or quasi-experiments? So quasi-experiments are used when a researcher is interested in a certain independent variable that can't be randomly assigned, right, in regards to his hypothesis. So in this case, we're talking about innate qualities like personality traits. Also, you could say race, right, racial ethnicity. That's an innate quality that can't be randomly assigned. So if we're looking at how do personality traits of people who score high in certain areas of personality tests, Big 5 personality test, how does that impact intelligence scores? In a true experiment, each participant would be randomly assigned to a personality group, right? Regardless of whether or not they possess that actual personality trait. This would be a flawed experiment because you wouldn't be able to actually measure people who were within that personality trait in their intelligence. So in this case, after participants take a personality test, the researcher would then assign them to groups and then test their intelligence, trying to measure the dependent variable, okay? So quasi-experiments are a little bit different from true experiments in the sense that you can't use random assignment. So the disadvantages, obviously there's advantages to them in the sense that you still get to test and see certain cause and effect relationships between innate qualities and behavioral qualities and mental processes. But the disadvantages is that with these types of experiments, the independent variables are not subject to random assignment. So there could be some other type of confounding variable that's not necessarily being controlled in this experiment that's kind of out of the researcher's hands. Okay. Now you have the independent variable and the dependent variable. You can't get these confused. So let's talk about the difference in both of these and make sure that you understand these. Okay. You can get them switched around real easily. So the independent variable is the variable in which the experimenter manipulates. Okay, it's kind of known as it's the cause variable. It's the variable that causes the effect. So in this case, the independent variable is going to be the caffeine, and the dependent variable is the variable that is the outcome of the independent variable. All right, so in this case, it would be the teacher's happiness. So the purpose of an experiment is to find out whether changes in one variable cause changes in the other variable. In this case, x would be the independent variable. X causes y. Okay, x is the reason for y. So x is the independent variable, caffeine. Y is the effect, my happiness due to that latte. Okay, so let's do a little bit of practice here. Okay, developmental psychologists want to know if exposing children to public television improves their reading skills. What is the independent variable and what is the dependent variable? The answer is the IV is exposure to public television. Dependent variable is reading skills. Okay, let's do a few more. Okay, the answer would be reinforcing comments for the IV and harder work on an assembly line would be the dependent variable. Okay, the independent variable would be the type of monkey, cloth or wire, in presence of nourishment. Right, and then the DV would be the presence of young monkeys. Let's do one more. The answer to that would be independent variable, psychotherapy, and dependent variable, future problems. Okay, so hopefully you guys did all right on that. And now we're going to look at just a few more terms here in regards to experiments and how we can design experiments. So we talked about this already. We talked about random sampling. You also use it in experiments as well. If you don't have a representative sample, it cannot be generalized to the public. In this case, what we could do is maybe we could use a computer generator, right, to randomly select 100 licensed teachers, and we'll make it representative. So 50 male, 50 female listed here within the Hong Kong EDV system. Okay. That would be a random sample. Now that I have my random sample of 100 teachers, I can randomly assign them into the experimental group and the control group, right? So there's also something here called a stratified sample. You might see this on the AP exam. I don't think it's in your book, but the stratified sample is a subcategory, basically. So you have subcategories, relevant subcategories within the random sample, and this could be like if you're talking about teachers, just school teachers, it would be high school teachers, middle school teachers. Or if you were just looking at high school, you could say disciplines, fields, social sciences versus hard sciences versus mathematics. Okay, so that would be seen as a stratified sample, just a subcategory, a relevant subcategory. Now, when we looked at random sampling, okay, why does random assignment matter? And how does that help establish cause and effect? Well, once researchers have established their hypothesis, their independent variable, their dependent variable, their random sample is now obtained from the population, they can go forth with random assignment into their experimental groups and their control groups, which we'll talk about here briefly in the next slide. But The random assignment is where the researcher randomly assigns the population that's already been kind of condensed down to a sample size and puts them into these different groups. So a random assignment minimizes, what it does is it minimizes pre-existing differences between the two groups. So it ensures that possible confounding variables don't come up, right? In this case, the confounding variable would be related to bias of the researchers' grouping techniques, okay, of who goes to the experimental group and who goes to the control group. So together with random sampling and with random assignment, researchers have a much better chance of getting an authentic result due to the independent variable, the cause variable, and not some other confounding variable, right? You want to prove that X is causing Y. And if you have possible confounding variables that are getting in there, the probability that X is causing Y is less. So other confounding variables besides looking at random assignment would be a lot of different things, right? Anything. It could be anything that is affecting the outcome of the experiment. The experimental group and the control group need to be almost identical except for the independent variable. It should be the only thing that is different, right? So if we look at this hypothesis, caffeine helps keep school teachers more happy, all right? How do I hold that constant? And I've got to take into consideration that there might be other confounding variables, right? And that could be any of these three, right? The amount of sleep that person had the night before, could be just their tolerance level. Let's say they drink 6 cups a day, and then I bring them randomly into my population and my assessment, into my study, and then of course they're, it's going to affect them less, right? Because they're tolerant to it. Or the fact that if I'm giving the second drink is decaf coffee, there's still a small amount of caffeine even in decaf coffee. So any of these things could affect my research, right? And the key quality that separates a talented researcher in terms of the experimental method from a mediocre experimenter is that one who is very talented can foresee these troublesome extraneous variables. So any extraneous variable outside, you want to contain that before it becomes a confounding variable. You want to avoid confounding variables at all costs in your experiment. Now the last portion here that we're going to look at in terms of terms that you need to make sure you understand and know is the experimental group and the control group. We've already referenced them quite a bit, so you probably already have an idea of what I'm talking about. But the experimental group is the group that receives the treatment. The control group is the group that doesn't receive the treatment. It's pretty simple, right? So in this case, the experimental group is the one that receives the caffeinated drink. Control group is the one that does not receive a caffeinated drink. Now both are technically receiving some kind of independent variable, right? They're both exposed to some kind of independent variable. They're both receiving a drink, okay? Whether it's caffeinated or not, but they are receiving something. Don't get that confused. Don't think that only one group receives something and the other group doesn't receive anything at all. Now again, you're looking at, hey, does the independent variable cause any difference between the experimental group and the control group? Is X actually affecting Y? And so through these two groups, you're generally able to see whether or not your independent variable is causing a difference between the experimental group and the control group. Okay? So lastly, we're going to talk about validity, as we've talked a bit about reliability, which can be given through operational definitions as you're trying to make your research more repeatable for those who look at your research and want to also give it a shot and see how reliable your research is. But validity is something that is more so about what we're measuring. Are you measuring what you're predicting? Okay? Is your measurement accurate? Are there other confounding variables? So there's this continuum scale from external to internal validity. And external validity is going to be more natural, right? Like naturalistic observations or even surveys, okay, which would be a quantitative method. Correlational studies, we can't have true cause and effect. So you've got this continuum scale. But when it comes to internal validity, we have quasi-experiments and true experiments. And quasi-experiments, again, they're not going to be quite as internal. They're not going to have quite as much internal validity as they don't have true random sampling. But again, nothing is absolute in terms of science. Science is not absolute, but it does help us answer questions. and gives us a bit more objectivity to that which we're searching answers for. Okay, so I'm going to just have you guys go ahead and practice your terminology from what you learned today through experiments. So go ahead and read this example, and then I want you to try to identify the IV, the DV, the population, this control group, experimental group, random sample, random assignment, and possible confounding variables. And then I will post the answer for you at the end. All right? So that's it for today, everyone. Have a great rest of your day.